Good morning, students. This is chapter number 10, Wave Optics. And today's topic is Intensities of Interference Fringes. Interference fringes means the maxima and minima, right? If there is a maxima on the screen, right? For example, at the center we get bright band. So this is called bright fringe or bright band or maximum, and alternate dark and bright bands appear on the screen in interference phenomena. So these are called fringes. This is dark fringe, this is bright fringe. So alternate dark and bright fringes appear on the screen due to superposition of light waves, right? We have already calculated the amplitude of resultant wave. For example, there are two sources, monochromatic sources, and moreover these sources are coherent sources, right? So the interference pattern appear at the screen due to superposition of wavelets. For example, S2 source is emitting this wave and S1 is emitting this one. Now the superposition takes place at point P. Then the resultant amplitude of the wave or resultant wave will be A is equal to root A square plus B square plus 2AB cos phi, where small a is the amplitude of wave coming out from S1 source, whereas B is the amplitude of wave coming from to S2 source. Then the resultant wave formed at point P and the amplitude will be given by this. Now phi is the angle or the phase difference between these two wavelets, and this phase difference remains always constant, right? So if amplitude is this much, the intensity is directly proportional to square of amplitude of the wave. Means the intensity of light will depends on capital E. So we can write I is directly proportional to A square. So I is directly proportional to A square plus B square plus 2AB cos phi, right? Now these are the conditions which we have already calculated. The condition for constructive interference was the phase difference between the waves is this one. For constructive interference, the phase difference should be A1 multiple of pi and path difference should be integral multiple of lambda, right? In case of destructive interference, the phase difference should be odd multiple of pi and the path difference should be 2n plus 1 into lambda by 2. It means odd multiple of lambda by 2. In the case of constructive interference, intensity becomes maximum and intensity directly proportional to A plus B whole square. Whereas the minimum intensity or the intensity of destructive interference or the dark fringe is directly proportional to A minus B square, right? Now distribution of intensity. How the intensity of light distributed over the surface of screen, right, or on the screen. Now see, this is the origin, means the center of the screen. This O point is the center of the screen. This is the intensity axis and these are the positions, means on positive axis this is the upward direction of screen. We are going in upward direction from its center, and negative direction shows that we are going below the center of the screen. Now intensity distribution is like this, means at center of the screen intensity is maximum, whereas in both side we got alternate at dark and bright fringes. Now all fringes have same width. You have already calculated the intensity, this width of the fringes are d lambda by d, means the intensity of, the width of all fringes will be same, and that will be equal to capital D lambda divided by small d. And the intensity of all maxima or bright fringes will be same, right? Now, if both the waves, both the sources which are producing the light waves have same amplitude, then what will happen? The maximum intensity will become A plus A whole square. It means I maximum will be directly proportional to 4A square, right? And in case of minimum intensity, it will be 0. Since it is A minus B whole square, it means A minus A whole square, it means intensity minimum will be 0. So maximum intensity will be 4A square and minimum intensity will be 0. So the intensity of maxima will be directly proportional to 4A square and intensity of dark fringe will be 0, right? Now, condition of sustained interference. Conditions of sustained interference means the conditions in which the regular interference pattern to be appeared. Number 1. Two sources producing interference must be coherent. First condition is that both the sources should be coherent. Number 2, the two sources should have the same plane of polarization, means they have same plane to travel, right? Means both the sources will have same plane. Number 3, the two sources must be very close to each other, means the sources should be very close to each other, right? And the pattern must observe at a larger distance to have the sufficient width of fringes, right? It means if there are two sources, the separation of sources should be very small, right? S1, S2 should be close to each other. And the screen where your observations are taking place, that should be at larger distance, means capital D should be greater, right? This distance should be greater. Got my point? Now, fourth point is sources must be monochromatic sources. Otherwise, fringes of different colors will overlap to each other. These sources should be monochromatic sources, means producing the light wave of single wavelength, right? Last, the two waves must have same amplitude for better contrast of bright and dark fringes. See, the first wave have amplitude A and second one have B. If A equal to B, the maxima will be maximum intensity, where minimum will have intensity 0, right? Now, comparison of intensities of maxima and minima. Now, this is intensity of maxima directly proportional to A plus B whole square, and minima, I minimum is directly proportional to A minus B whole square. Now see, this is the intensity of constructive interference, means the bright fringe or the maxima or the bright fringe. This is the intensity of minima or dark fringe or dark band, right? Now, if we divide equation 1 by equation 2, we get I maximum by I minimum is equal to A plus B whole square divided by A minus B whole square. Now, this equation can be divided by B, numerator and denominator. So, we will get A by B plus 1 whole square divided by A minus B minus 1 whole square. This A by B is the ratio of amplitudes of first wave or first source and second source. So we can get this ratio R is this, right? Now see, relation between intensity, amplitude and width of the slit. Width of the slit means if there are two slits, so this is called width. Width of the slit, W1, and this is W2. So what is the relation between intensity of light, amplitude and width of the slits? See, I is directly proportional to A square. So this is the relation between intensity and amplitude. Now, amplitude is directly proportional to square root of width. Higher the width, higher the amplitude of wave. It means amplitude is directly proportional to root W. So we can write it as I1 by I2 is equal to A1 square by A2 square is equal to W1 by W2. So we can write it intensity is directly proportional to width. So sometime in board examination we have asked the question related to this formula. For example, if the intensity of two individual waves is in the ratio of 81:1, right? The ratio of intensity of two individual waves 81 and 1. Find the ratio of their amplitudes. So what will happen? That ratio will be 9:1. Right? If the intensity ratio is 81:1, it means amplitude ratio is 9:1. As you know that this is the relation between amplitude and intensity. Now, what will be the ratio of maxima and minima? Maximum intensity and minimum intensity. What you will do? We will keep here 9/1. In place of A by B, we should substitute 9/1. So it will become 9/1 plus 1 means 10. So 10 is square of 10 is 100, right? And 9/1 means 9 minus 1 8. So it will be 64. So the intensity ratio of maxima and minima will be 100:64. This sort of question asked in the board examination in previous years, right? So this is all about the interference. Now from next lecture we will discuss about the diffraction of light. Thank you very much.